Hi, this is Mr. Ng, and I want to review what we learned in class today. So the first thing we recognize is that this is in descending order. Descending, think like you're going down a mountain. Descending order refers to the exponents, that small number on top right of the variable. So this is a 2, this would be an invisible 1, and that would be actually a invisible x to the 0. So you'll notice that to know that it's in descending order is then based upon the exponent. So make sure it's in descending order. 2, 1, 0, D for going down, descending. The next thing we learned is that you could take their coefficients. Coefficients are just a fancy word for numbers in front. So there, our A value is equal to 1. Your B value is in front of x, not 7x, but B is equal to a positive 7. Now, I don't need to write a plus there because we already know it's implied it's positive. And then your C value is a positive 12. So first thing you're going to do is just find the A, B, and C. The second thing you're going to do is fill out this x. And in this x now, you're going to multiply the letters A times C. So take your A value, and you're going to multiply that by your C value. So A times C, or 1 times 12, is just 12. And then you're going to get your B value down here, and that is 7. So to help you there, we've got some colors here. Here you need to think of two numbers that their product, or that's a fancy word for multiply. If I multiply two numbers together, they will equal 12. But those same two numbers, their sum, or if you add them together, will equal 7. Well, one strategy you can do is list out all the prime factors of 12. That is 1 times 12, 3 times 4. Notice how 3 times 4 and 4 and 3 are the same thing, right? And then 2 times 6. Let's say if I took 2 times 6, that would equal 12, but 2 plus 6 is not 7, it's 8. So I can't use that one. Let's try this one. 3 times 4 equals 12. 3 times 4 equals 12, and 3 plus 4 also equals 7. Okay, so now that we've gotten our x, we can use the box. Now, if I were a student, I'm telling all my students just do both the x and the box. But as you're doing it, you might recognize a pattern when to use the x and when to use the box. All right, in the top left, you will always put, here in yellow, in the top left, in this case, the ax squared, so this would just be x squared. Okay, and in the bottom right, you're going to put in, always, you're going to put in the C value, so 12. Now you're going to take the 3 and the 4 and you're going to put them here, and you're going to add an x. Now it doesn't matter, you could have switched those, that would have been okay. Now you need to think of two expressions that multiply together that equal x squared. That is x times x. X times something equals 4x. That'll be a 4, and that 4 is positive. 4 times x equals 4x. X times something gives you 3x. Well, that would be a positive 3. You can also think of it as backwards, as what we did in the previous lesson is making expressions into prime factors, or just factors. So 3x is 3 times an x, right? And you'll actually see that what they have in common here is this row, they have an x in common. And you'll recognize going this direction, they actually have a 3 in common. Do you see that? And then you can double check, 3 times 4 is 12. So these are my binomials. Let's write that. Equals. Now, as you're writing these binomials, order does not matter, because you can write 4 times 1, that's 4. Or 1 times 4 is also 4, commutative property of multiplication. So here's my answer. The reason why I write an equal sign is to show that these are equivalent expressions. So the quantity x plus 3 times x plus 4 is my answer.